The University of the Philippines College Admission Test, also called UPCAT, is processed in several phases. We will only be discussing the algorithm on how students are granted their slot in UP from the year 2006. UPCAT processing has required input of student identification, their first and second preferred program course in their selected UP campus, and computed predictors from the entrance exam and grades from high school. The computing predictors are University Predicted Grade or UPG, Mathematics Predicted Grade or MPG, Biological Science Predicted Grade or BSPG, and Physical Science Predicted Grade called PSPG. After the process, it should have an output list of students that UP will accept as their freshmen in their respective programs. These students have performed better than those who were not selected. Their performance was measured through their UPCAT and high school grades. The solution algorithm ranks the students based on their computing predictors. Again, the predictors are UPG, MPG, BSPG, and PSPG. Then, the students are assigned to programs they have indicated. As a program course is populated by students, the program handlers will be starting to separate students which cannot be admitted to the program course. Each degree has a limited number of students they will be accommodating for freshmen. This is known as quota. The quota is determined by the program handlers, and meeting a quota means passing the program quota. If a student does not meet the quota of his first preferred program, then he will be checked for his second preferred program. When a student does not meet the quota for his second preferred program, then he will have no program and has not secured a slot in UP with his preferred program course. However, not all hope is lost for students that have no programs, as they are added to a list called Campus Sync. In cases where program courses have not met their quota, or there may be changes in the program list, they are automatically next in line as candidates. When a program has met its quota and is in the process of selecting students, there may be a case when students have the same computed predictors and the number of students would be above the quota. Removing the tied students will make the program not meet its quota, so the students are not removed from the program list until more students qualify in the quota. When more students qualify, the tied students are removed, which will result in the program meeting its student quota. The solution algorithm uses doubly linked circular list with a list head. A student is represented by a node with the following fields: L-link, student ID, first choice course, second choice course, UPG, MPG, BSPG, PSPG, current course choice, 1 for first, 2 for second, and R-link. A circular doubly linked list allows us to have quick traversal at the tail node. It features linked traversal forward and backward, which is important for faster node insertion. Because node insertion requires a pointer to the previous node, using a doubly linked list gives the pointer immediately rather than traversing the list. The nature of the solution frequently removes nodes at the end of a program list. Since lowest computing prediction nodes are being removed, a doubly linked list would be ideal, and list traversal to the tail node is minimized by traversing backward from the head node. When a student is being considered for a program, it is compared to an ordered list of the students based on the predictor of their program. If the student has a predictor within the list of students, then he is inserted in the list in order. When the student population in a list has met its quota, the student node is subject to reassigning values of its L-link and R-link of a student who is ranked lowest based on the predictor. A circular linked list is used because searching a student list and removing them is also faster.